They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth. The posts claim that the telescope captured the object changing its trajectory.
The faint glimmer of a swan-shaped cosmic body, long debated and only partially hinted at in fragments of light and spectrographic data, has finally been captured in a true image by the James Webb Space Telescope. The object, known as R2 Swan, once considered more of a myth than a certainty, revealed itself in striking clarity as Webb's infrared instruments cut through the haze of interstellar dust and presented astronomers with a sight that has eluded human vision for decades. It was not just another cometary body, nor simply a gaseous artifact wandering the void. This was the first undeniable, high-resolution visual confirmation of a celestial entity whose very nature had been argued over in observatories across the globe. To see R2 Swan emerge not as a simulation or an artist's impression, but as a real and intricate form in the universe, marks a milestone in how humanity connects its theories to evidence. Before we start, smash the like and subscribe buttons for more updates. The telescope's near-infrared camera was responsible for the revelation, drawing from its unprecedented sensitivity to faint light sources. R2 Swan had been registered faintly in datasets before, especially during prior surveys with Hubble and ground-based observatories. But none of those instruments could bypass the shrouding layers of cosmic fog. What appeared then were incomplete arcs, diffuse streaks, and spectral anomalies that hinted at a larger structure but never gave a definitive shape. Webb's new capture changed that narrative in an instant. The image unveiled the swan-like curvature, the luminous arc trailing like a feathered wing, and the dense glowing core at the heart of the structure. For astronomers and astrophysicists, it was like the difference between hearing faint whispers of a song and finally experiencing the full orchestration. The implications begin with sheer scientific validation. For years, R2 Swan had occupied a twilight zone between confirmed body and theoretical construct. Its presence was tracked indirectly, inferred from the gravitational pull on surrounding dust and gas. Some argued it was nothing more than a misinterpreted collision of cometary debris. Others suggested it might be a transitional object, a hybrid between cometary core and interstellar visitor, moving on an orbit that made it difficult to classify. With Webb's image, those speculations are now grounded in actual data. The sharp detail of its nucleus, the layered patterns of its outflowing gases, and the clear delineation of its trajectory provide concrete evidence that this object is real, stable, and distinct from the ephemeral streaks once confused with it. More than validation, though, the image introduces a frontier for exploration. By exposing the composition of R2 Swan's glow, Webb has given scientists a chemical fingerprint. Its light, parsed through Webb's spectrographs, carries information about volatile compounds, ices, and organics clinging to its surface. The swan-like shape, far from being purely aesthetic coincidence, may be the result of asymmetric outgassing driven by these compounds. When energy from a nearby star or from cosmic rays excites the molecules, plumes erupt unevenly, sculpting the elongated wings that made this object so visually distinct. This dynamic behavior suggests a laboratory in space, where physical and chemical processes can be observed in action, almost as if a natural experiment had been set up for human instruments to study. The excitement radiating from this discovery stems from its rarity. Not every comet or interstellar body reveals itself in such dramatic form. Most comets dissolve into diffuse tails, predictable and repetitive in their returns. R2 Swan, however, bears traits that make it feel like a one-of-a-kind phenomenon. Its brightness shifts, its orbital irregularities, and now its unique structure all separate it from the catalogs of icy travelers that have been tracked since antiquity. It does not belong comfortably within a class, which means it may force astronomers to redefine categories of small bodies in the solar system and beyond. If it is interstellar, then it joins the ranks of Oumuamua and Borisov as rare messengers from outside, carrying material from star systems other than our own. If it is solar in origin, then its survival in this strange form poses questions about the dynamics of our system's outskirts, where such bodies form and evolve. Webb's image also resonates with a broader audience outside professional astronomy. To the public, the swan-like curve inspires awe because it transforms abstract science into something visually poetic. The cosmos is filled with objects given metaphorical names: horseshoe nebulae, crab pulsars, cat's eye nebulas. But R2 Swan's likeness is not just naming convention. It is unmistakably avian in profile, a silhouette that draws immediate recognition. This kind of discovery engages not only the scientific mind, but also the imagination, strengthening the bridge between complex astrophysical data and the human sense of wonder. People see themselves in these cosmic shapes, connecting celestial events to earthly life, and in that connection lies the power of inspiration. The practical implications for science are immense. The image is not simply aesthetic. It allows calculations about mass, density, and energy output that were impossible before. By measuring the intensity of light at different wavelengths, scientists can derive the distribution of compounds across the swan's form. Early interpretations suggest a higher concentration of carbon-rich material than expected, which could revise assumptions about the chemistry of such bodies. That matters not only for classification, but also for theories about how building blocks of life are distributed across the galaxy. If bodies like R2 Swan are common in certain regions, they may act as carriers of complex molecules, scattering them like seeds into planetary systems. This connects to the broader search for origins, how water, carbon, and other essentials arrived on worlds like Earth. Another implication rests in dynamics. R2 Swan's trajectory is unusual, and now that Webb has provided a precise visual anchor, astronomers can refine its orbital path with new accuracy. Whether it is bound to the solar system or passing through from elsewhere remains an open question. If interstellar, it brings information from another system's birth cloud frozen for eons before arriving here. If native, it reveals unknown processes at the edge of the Oort cloud or Kuiper belt. In either case, its path becomes a story of cosmic travel, and understanding it could help identify other such objects before they arrive. The telescope's ability to catch it at this level of detail suggests a future where Webb and its successors will not only identify but also predictably image such elusive visitors. The timing of this image also carries symbolic weight. Humanity is at a point where multiple telescopes, ground-based giants, orbital instruments, and deep space explorers are working in concert. Yet it is Webb, with its unparalleled infrared sensitivity, that pierced through the obstacles to reveal R2 Swan in its true form. This underlines the importance of sustained investment in advanced technology. Without Webb's capability to cool its instruments to near absolute zero and detect the faintest glows in infrared, this discovery might still be a whispered debate rather than a clear image. It demonstrates how each leap in technological ability does not merely extend current knowledge, but opens windows onto phenomena never before accessible. The image of R2 Swan also brings with it the excitement of mystery. While it confirms the object's existence, it raises new questions that will fuel research for years. Why does it hold its unusual shape? What internal structure allows it to maintain that swan-like profile instead of disintegrating into randomness? Could there be magnetic fields, rotational forces, or other hidden mechanisms shaping its form? Each answer may spark more questions, driving a cycle of inquiry that pushes the limits of astrophysical theory. That is the beauty of such firsts. They mark both an end to uncertainty and a beginning of deeper exploration. This event also echoes through culture. Since the dawn of human history, comets and unusual celestial bodies have been regarded as omens, myths, and symbols. Now, with the image of R2 Swan, a new chapter in that tradition unfolds. The swan has long been a symbol of transformation and beauty across civilizations. To find its likeness inscribed in the heavens is to connect ancient symbolism with modern discovery. In literature and art, it will inspire interpretations just as the rings of Saturn and the spirals of galaxies have done. It reminds humanity that the universe speaks in forms and metaphors that resonate beyond equations, reaching into the realm of shared human experience. On the scientific frontier, the confirmation of R2 Swan redefines what astronomers expect from future Webb discoveries. If such a unique object can be imaged so clearly, then other faint anomalies may soon follow. The telescope is still young in its mission, with years ahead to scan the depths of space. Each anomaly that was once dismissed as noise or artifact may now be reconsidered as a potential revelation. The precedent has been set. The cosmos contains surprises waiting for instruments sensitive enough to see them. R2. Swan's unveiling becomes a message that patience and persistence are rewarded with extraordinary insight. The capture of this first true image will also fuel collaboration across scientific fields. Chemists, Physicists, planetary scientists, and astrobiologists will all find data within the Webb observations that relate to their specialties. For chemists, the spectral data offers insight into carbon chains and exotic ices. For physicists, the dynamics of its jets and plumes provide a case study in forces at extreme scales. Planetary scientists will connect it to models of solar system evolution, and astrobiologists will weigh its contribution to theories about life's chemical beginnings. This interdisciplinary convergence is one of the most valuable outcomes of Webb's work, discoveries that ripple across domains of knowledge. The emotional resonance of this moment cannot be overlooked. To look at R2 Swan, to see it not as a streak of uncertain data, but as a real celestial form, is to be reminded of humanity's capacity for exploration. The cosmos is vast, often overwhelming in its scale and silence, but within it exist moments of clarity that tie human effort to cosmic truth. The James Webb Space Telescope has not only shown what is possible technologically, but has also given a generation an image that embodies curiosity fulfilled. It is a symbol of what can be achieved when patience, vision, and ingenuity converge in pursuit of the unknown. And so, the first real image of R2 Swan stands as a milestone. It is a confirmation of existence, a source of new questions, a bridge between science and imagination, and a testament to the power of advanced instruments to reveal the universe in forms we could scarcely anticipate. What was once speculative is now visible, and what is now visible will inspire inquiry for decades to come. In the faint glow of R2 Swan's wings, humanity finds both proof and poetry, and in that dual gift lies the enduring legacy of this extraordinary capture. Every astronomical age is defined by a handful of rare discoveries that break from the ordinary catalog of stars, comets, and nebulae. R2 Swan belongs to this class of rarities. It resists easy classification, forcing scientists to expand their taxonomies. What makes this moment extraordinary is not simply the confirmation of an unusual object, but the possibility that its existence suggests an entire category of similar phenomena that has so far remained hidden. The cosmos is vast, and objects that do not conform to expected behavior often escape detection. Webb's capture of R2 Swan provides a proof of concept. Anomalies are not mistakes in data, but potential indicators of phenomena never before encountered. The notion of rarity in astronomy carries scientific weight. Rare bodies often hold the key to unexplored processes. Just as the first sight of pulsars reshaped understandings of stellar collapse, or the identification of quasars expanded the scale of cosmic energy release, the swan-like body could represent a new phase in the life cycle of small bodies drifting between stars. Its rarity may also point to unique conditions of formation. Perhaps it originated in a star system with unusual chemical balances, or in a collision event that produced asymmetrical shapes instead of the usual spherical or elongated bodies. In either case, studying this rarity forces a re-evaluation of the processes that generate and sculpt the architecture of matter in the universe. What makes the Webb image particularly important is the way it demonstrates the future potential of infrared astronomy. Visible light telescopes would never have pulled R2 Swan out of the background noise of cosmic dust and faint starlight. Only in the long, cool wavelengths of infrared can the faint heat signatures of frozen bodies reveal themselves. This lesson extends beyond this discovery. It shows that countless other faint objects, buried in regions where starlight cannot reach, may be awaiting similar revelation. Infrared imaging is not only about clarity, but about expanding the census of the universe. If Webb can reveal one swan-shaped body, it suggests there are thousands of other overlooked entities, their signals lost in the limits of past instruments. The telescope acts as a lantern in dark waters, illuminating life where once there was assumed emptiness. This shifts not only astronomy's present, but its roadmap. Future instruments must be designed to chase these subtle signals, making infrared sensitivity central to exploration. R2 Swan is more than a visual spectacle. It is a natural laboratory for studying chemical interactions in environments far beyond Earth. Its surface, laced with volatile compounds, behaves like a reactive canvas where cosmic rays, ultraviolet light, and gravitational stress trigger processes unseen in controlled laboratories on Earth. To study such an object is to peer into chemistry conducted under conditions that humans cannot replicate. This has implications not only for planetary science but also for the origins of life. The distribution of organic molecules in interstellar bodies carries clues about how life-friendly chemistry emerges. If R2 Swan reveals high concentrations of carbon-rich ices, amino acid precursors, or exotic chains of hydrocarbons, then it adds evidence to the idea that life's ingredients are not unique to Earth but are abundant, scattered widely across the galaxy. The swan-shaped structure could even provide insights into how asymmetrical energy release from plumes or vents influences the distribution of organic compounds in space. This knowledge ripples outward to theories of panspermia and planetary seeding. The most striking feature of R2 Swan is its form, the unmistakable sweep of wings and the glowing body that suggests deliberate shape. This raises fundamental questions. Why does matter in space sometimes assume forms that resonate so strongly with recognizable patterns? Are such shapes purely coincidental, the byproduct of chance outgassing and orbital stresses? Or do underlying physical laws have a tendency to produce symmetry and elegance even in chaos? The swan's form demands study in terms of dynamics. Its plume activity might be shaped by rotational forces, where jets erupt more strongly from specific latitudes. Alternatively, internal fractures in the body could channel gas through certain exits, sculpting wings in the process. The interaction of solar radiation pressure with these plumes could then sustain the distinctive silhouette. In this way, R2 Swan becomes a case study in cosmic sculpture, where invisible forces act as chisel and brush. The significance extends to aesthetics as well. For centuries, humans have assigned shapes to constellations and nebulas, overlaying imagination onto random scattering. But when the universe itself presents a body with form so distinctly avian, the relationship between perception and reality grows complex. Are we seeing what we expect to see, or is the universe producing forms that align with archetypes? This tension between human imagination and cosmic design adds philosophical weight to the discovery. R2 Swan's orbit remains a mystery, and Webb's image provides the key starting point for resolving it. Its precise coordinates and visual form allow scientists to triangulate its trajectory more accurately than ever before. Early models suggest it follows a path that does not fit cleanly with the orbits of solar system comets. This irregularity could mean it is an interstellar traveler, visiting for a brief window before vanishing into the dark again. If true, then Webb has captured not just a unique object, but a rare event in motion, the brief passage of a wanderer from another star system. If, however, it proves bound to our system, then its orbit may reveal hidden structures in the Oort cloud or Kuiper belt. Perhaps gravitational interactions with distant giant planets shaped its unusual path. The ability to calculate this precisely has wider consequences. Understanding the flow of such bodies helps predict potential cometary intrusions into the inner solar system, informs planetary defense strategies, and refines simulations of long-term orbital mechanics. R2 Swan, then, is not just visually beautiful, but practically useful in refining our grasp of celestial motion. In recent years, objects like Oumuamua and Comet Borisov have electrified science as interstellar visitors. R2 Swan may join that lineage, but with a twist. It presents a visible and iconic form unlike anything recorded before. The lesson is that interstellar objects are not just random debris. They may carry signatures of the systems from which they came. Each one is a messenger, bearing the imprint of distant star nurseries. If R2 Swan is such a traveler, then its shape and chemical makeup may encode the conditions of a far-off stellar system that humanity has never observed directly. This extends the narrative of cosmic interconnectedness. The solar system is not isolated, but constantly intersected by emissaries from elsewhere. Each visitor expands the horizon of our awareness. In this sense, Webb's image is not only a scientific snapshot, but a reminder of cosmic community, that the galaxy is a place of ongoing exchange, with material flowing across unimaginable distances. One of the less discussed but no less important aspects of such a discovery is the psychological effect it has on humanity. Images like this shift perspectives. For centuries, people have looked upward to stars and sought meaning. The swan shape brings an immediacy to that search. Unlike abstract data, it presents a visual anchor that stirs recognition and emotion. Seeing a swan-shaped figure in the heavens connects cosmic vastness to something intimate and earthly. Psychologists studying the human response to space exploration note that such events foster unity. People from different cultures see in the swan a symbol of grace, transformation, and transcendence. This creates a shared language across cultural divides. In an age of fragmentation, such shared experiences carry weight. The Webb image is not only a scientific triumph, but also a cultural artifact that reshapes how people imagine their place in the cosmos. R2 Swan will inevitably inspire art, literature, and cultural interpretation. The visual resemblance to a swan will echo across poetry, music, and visual arts. Artists have always drawn inspiration from celestial discoveries, from Van Gogh's swirling stars to the cosmic landscapes of modern digital creators. This new image provides raw material for imagination, inviting reinterpretation in human stories. Swan imagery is particularly rich. In mythologies across the globe, swans represent love, transformation, purity, and mystery. In Hindu tradition, the swan is associated with the ability to separate the eternal from the transient. In European lore, swans embody fidelity and tragic beauty. To see this archetype reflected in the sky connects cultural memory with astronomical reality. It suggests that the cosmos, in presenting forms that echo archetypes, continually participates in human storytelling. Webb's success in capturing R2 Swan sets the stage for future missions. Already, the astronomical community anticipates the Nancy Grace Roman Telescope, which will provide wide-field infrared surveys. Combined with Webb's focused precision, these instruments will work in tandem to locate and detail anomalies like R2 Swan. The future of discovery lies in this synergy: broad sweeps of the sky to identify candidates, followed by deep, focused imaging to resolve them. Moreover, the success of Webb demonstrates the importance of designing instruments capable of exceeding expected parameters. R2 Swan was not on anyone's initial roadmap for Webb. Its capture represents the unforeseen, the serendipitous. That lesson will guide future missions, to build instruments not just to answer known questions, but to embrace the unexpected. In that sense, R2 Swan is not only a discovery, but a compass, pointing toward the design philosophy of tomorrow's exploration. Perhaps the most enduring dimension of R2 Swan lies in the philosophical questions it inspires. Why does the universe present itself in ways that resonate with human perception? Is the swan-like shape merely coincidence, or does it reveal something deeper about pattern and form in the cosmos? Philosophers of science may argue that humans project meaning onto randomness, but even so, the projection itself has significance. It shows how discovery is never purely detached observation. It is always filtered through perception, imagination, and the search for meaning. This does not diminish the scientific rigor of Webb's achievement, but enriches it. The swan's form becomes a site where science and philosophy meet, where empirical observation intersects with symbolic interpretation. It reminds us that discovery is not only about data, but also about how humanity integrates that data into the broader fabric of understanding. The capture of R2 Swan by the James Webb Space Telescope is not a single event to be checked off in the ledger of astronomical milestones. It is a multi-layered moment that continues to unfold in significance. Scientifically, it redefines categories, expands the reach of infrared exploration, and provides a new laboratory for chemistry and dynamics. Practically, it refines orbital science and planetary defense. Culturally, it inspires art, connects myth with reality, and fosters unity through shared wonder. Philosophically, it raises questions about perception, pattern, and meaning in the cosmos. In all of this, R2 Swan transcends its immediate identity as a celestial body. It becomes a mirror in which humanity sees its own curiosity reflected, a symbol of the interplay between chance and order, and a reminder that the universe still holds surprises waiting for the right eyes to behold. Webb has provided those eyes, and in doing so has illuminated not only a swan-shaped traveler, but also the boundless capacity of the cosmos to astonish. The unveiling of R2 Swan by the James Webb Space Telescope continues to ripple outward in significance, and even beyond the core scientific details and cultural echoes already discussed, there are fresh layers worth examining. The beauty of such a moment lies in its expansiveness. It cannot be contained within a single explanation or reaction. Each new angle opens yet another horizon, and the story of R2 Swan is still very much in the process of unfolding. To expand the exploration without repeating what has been said, it is helpful to turn toward other scientific, technical, and humanistic dimensions that enrich the meaning of this remarkable event. The James Webb image gives astronomers a rare, high-quality snapshot, but one picture alone cannot tell the full story. To truly understand R2 Swan, computational models are essential. These simulations can take the visual data and project forward, estimating how the swan-shaped body may evolve over time. By inputting variables such as gas emissions, spin rates, solar radiation, and gravitational influences, astronomers can model the shifting geometry of the wings and body. These models also allow for backtracking, rewinding the clock to infer the conditions under which R2 Swan formed. Did it originate from a collision that fractured a larger icy body, sending plumes out in asymmetric fashion? Did a slow accumulation of cometary material, subjected to uneven solar heating, gradually carve out its silhouette? Simulation becomes the key to turning Webb's frozen image into a dynamic narrative, revealing not just what R2 Swan looks like, but how it came to be and where it may be going. A fruitful way to expand the significance of this discovery is to compare R2 Swan with other known celestial bodies. While no object has ever presented itself in such a distinctly swan-like form, there are analogues worth exploring. Comets like Hale-Bopp or 67P/Churyumov-Gerasimenko exhibited unusual plumes and double-lobed structures, but they never reached the symmetry or artistry of R2 Swan. The comparison highlights just how unusual this body is. The lesson here is not only about uniqueness, but about pattern recognition. If scientists study dozens of similar bodies and find echoes, smaller wings, partial arcs, or fragmentary curves, then R2 Swan could represent the apex of a broader category. If, on the other hand, no comparisons yield anything close, then it underscores the extraordinary anomaly it represents. Either way, the act of comparison gives context, sharpening our sense of the body's place within the wider cosmic tapestry. Another unexplored dimension is the thermodynamic behavior of R2 Swan. Its glowing form suggests a complex interplay of heat absorption and emission. At distances where solar energy is faint, bodies like R2 Swan rely on delicate balances between trapped internal heat, radiative cooling, and external cosmic influences. By analyzing the gradients of its glow, scientists can infer how heat travels through its icy and dusty shell. This information has implications for understanding the thermal properties of other small bodies in space. If R2 Swan retains heat differently than expected, it could challenge assumptions about how icy bodies evolve when exposed to fluctuating cosmic environments. This knowledge matters not only for astronomy, but also for planetary science, since similar thermal processes shaped the early Earth and continue to govern icy moons like Europa and Enceladus. The appearance of such an object has practical consequences for astrodynamics, the science of plotting spacecraft trajectories. Unusual bodies like R2 Swan become both challenges and opportunities for space navigation. Their gravitational influence, though subtle, adds complexity to calculations of spacecraft motion. More importantly, unique objects present tempting targets for future missions. A spacecraft could, in theory, be dispatched to intercept R2 Swan, study its surface directly, or even sample its material. Such missions require precise astrodynamic modeling, which becomes possible thanks to Webb's imaging. The presence of an object with such distinct form and composition may inspire new mission proposals, much like how the Rosetta mission was conceived to study Comet 67PR2. Swan could become the anchor of a future exploratory voyage, extending its influence beyond observation into direct encounter. The visual beauty of R2 Swan derives from its interaction with light, and this opens a window into the physics of scattering and reflection. The wings appear luminous not because they are inherently bright, but because dust and gas scatter sunlight and starlight across their surfaces. By studying the intensity and angle of this scattering, astronomers can deduce the size and composition of the particles making up the wings. This information is crucial because the way light behaves in such contexts can refine models of distant exoplanets and nebulae. The same scattering principles apply to the atmospheres of planets far beyond our reach. In this sense, R2 Swan becomes not just a local curiosity, but a test case for universal principles of optics in space. Its swan-like glow is more than poetic. It is an experiment in cosmic light play. One might not immediately associate ethics with astronomy, but discoveries like R2 Swan raise subtle ethical questions. How should humanity treat rare and potentially fragile bodies in space? Should they be left untouched, observed from a respectful distance, or explored directly with probes that might alter their structure? These are not trivial concerns, especially as commercial space ventures grow more ambitious. R2 Swan, in its singularity, highlights the responsibility that comes with exploration. The temptation to mine, harvest, or exploit cosmic bodies must be weighed against the scientific and cultural value of preservation. Just as Earth's natural wonders are protected as heritage sites, rare cosmic bodies may one day require frameworks of guardianship. The ethics of how humanity approaches R2 Swan could set precedents for future interactions with the cosmos. R2 Swan is not only a subject for professional astronomers, but a powerful tool for education. Its striking form and the story of its discovery can inspire students and the public to engage with astronomy in new ways. Teachers can use the Webb image to explain concepts of light, chemistry, and orbital mechanics, transforming abstract science into something visual and relatable. Planetariums and museums will undoubtedly feature the Swan in exhibitions, drawing visitors who might otherwise feel disconnected from astronomy. Its iconic form makes it ideal for outreach. It is both scientifically important and aesthetically compelling. This duality ensures it will remain in public imagination for years, making it an ambassador of science to society. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on James Webb capturing R2 Swan's first real image? We want to hear from you. Thank you for watching, and see you next time.